Welcome back to Lane's ED Enhancement. It's been a while, but I've been putting together a number of videos to ensure that we are on a blast going forward. Now, today we will be starting the first episode of a series called Realistic Scenario. Realistic Scenario. So let us call this part 1. Today we will be going through some practical examples from the course Seaborne Cargo and Dangerous Goods. This is going to show us how we can utilize stowage factor to determine the number of a cylindrical cargo that can be packed in a rectangular container based on its payload. In this example, we are given the volume of the drum, the packed volume of the drum, in other words, the space that each drum will take up, and its stowage factor. Also, we are given the payload of the container they are to be packed in. Then the following questions are asked. A. How many drums of paint can be packed in a rectangular container with a maximum payload of 28 tons? Also, for B, how much cubic meters of paint is this? And C, what is the total volume of the cargo? Now, first we need to determine, based on this question, let us look at the solution for A. First, we need to determine the available volume or space in the given container using this formula. Stowage factor again, where we want to find the volume, we'll have transposed to make volume the subject, where volume is equal to W for weight times the stowage factor. Now the total volume of space in the container is equal to 28 tons at 2.27 cubic meters per ton. That is equal to 28 times 2.27, and that gives us 63.56. So now we know the actual space that is in the container. Now to determine the number of drums that can hold in this space, we continue by dividing the space 63.56 by the volume of one drum, 0.06 cubic meters. Therefore, 63.56 divided by 0.06 would give us 1059.33. But let us remember that drums are not in a fraction. So the 0.33 does not actually represent the drum. What it represents is the space that is available. Let us call it broken storage, and we're going to look at that. The broken storage space that would have been taken up because the drums are round and they are being loaded inside of a rectangular space or container. So let us look at broken storage space, which is the 0.33 of the drums. Now this picture is going to show round drums being loaded in a rectangular container, as you can see, and all of these arrows are pointing to the spaces that are there, which we call broken storage spaces. So bear in mind that since the drums are round and the space that they are going inside is rectangular, then you are going to have the space when they are packed together. These spaces will be created. Now let us look at B. How much cubic meters of paint is this? First, we must convert liters to cubic meters. And since 1000 liters is equal to 1 cubic meter, then converting 45 liters would be 45 divided by 1000, and that would give us 0.045 cubic meters. Then, since we have 1059 drums containing 0.045 cubic meters of paint, then 1059 times 0.045 would give us 47.655 or 47.66 cubic meters. That is the amount of paint that would be in the drums. In solving C, where we want to determine what is the total volume of the cargo, we must first understand that the drums are the cargo and not the paint. So the round drums have air spaces, which we have already identified as broken storage between them. So the drums could only be packed tightly if they were rectangular in shape. So the total number of drums being 1059, and we have already determined that the volume of each drum is 0.06 cubic meters, then we can say that the total volume of the cargo is 1059 times 0.06 cubic meters, which would give us 63.54 cubic meters. Now let us look at another example where we again are given the internal volume of a particular drum, or the packed volume of the drum, right? And we are also given the space. We are given the stowage factor, which is 3.52 cubic meters per ton. Again, we are asked how many drums of paint can be packed in a rectangular container with the maximum payload of 45 tons. B, they want again to know how much cubic meters of paint is this. And C, what is the total volume of the cargo. So in solving A, as we did previously in the first example, where we want to determine how many drums, we have the stowage factor formula, and for volume, it would be weight times stowage factor, which would be 45 tons at 3.52 cubic meters per ton, which is 45 times 3.52, and it gives us 158.4 cubic meters. Therefore, that being the space, and we know that the packed volume of each drum is 0.068, then 158.4 divided by 0.068 would give us 2,329.41 drums. But as we know again, that is only 2,329, as the 0.41 represents the broken storage. Let us again look at broken storage, which is space that is lost because the drums are round and they are placed into a rectangular area. Again, we look at all the spaces there and see that they are all classified as broken storage space because of the round drums being in this rectangular space and being packed together. Now, let us solve B. How much cubic meters of paint is this? Again, we have to convert liters to cubic meters, and we were given 55 liters divided by 1000, which is 0.055 cubic meters. Then multiplying the number of drums, which is 2,329, by 0.055, we get 128.1 cubic meters. That would be the volume of the paint. In solving C, and since we understand that the drums are the cargo and not the paint, and we also understand that round drums create air spaces which we call broken storage between them because they are packed in a rectangular area, then the total number of drums being 2,329 and the volume of each drum being 0.068 cubic meters, for us to determine the volume of the cargo, then we would multiply 2,329 times 0.068 cubic meters, and that would give us 158.37 cubic meters. Now, please join me the next time when we will continue with another episode in this series of realistic scenario. Remember to like, to share, comment, and subscribe to this channel to continue being enlightened. See you next time.